Hey guys, thought I'd come on and make another vid, complete what was discussing on the one yesterday. Wasn't able to fit it all in. Here is the Mount Mauna Loa Solar Observatory run for yesterday. I showed it to you last night. That was the unsanitized version. Here's the sanitized version. I think what I mean by sanitized is they somehow strip off the first few or several layers of altitude. So the closest stuff to the earth they strip away through a computer, of course, and so that takes out all the flying objects zipping around, but it also, and the energy spikes, and but it also gives a clearer picture of what is up there. And look at these big objects, and if you watch, they're moving. So that tells me they're pretty close to the earth for catching movement. This run is it's 120 frames, 122 frames. They're like 7 seconds shy of 2-minute time lapses in here. Judging by these times anyway. So we got, let's see. '18 to 25, so we got almost 7 hours here on the Mauna Loa Solar Observatory. Quite several objects up there. There's one there, one there, one there, 1, 2, 3. Looks like there might be one hiding in there. Maybe not. This one's always been up there. Maybe something over here. It usually is. But anyway, point being, I showed you the gap on ACE. We were getting the gap on Discover there for a couple days this week, about 8 hours early in the week. And now we got it on the ACE. It's an 8-hour gap, 23 UTC to 0700 UTC. And it is a data gap. Pulled up the ACE ground tracking station plots. These are all the different stations. You can see here, there's the gap. It's a 7-hour gap, or 8-hour gap rather. So that tells me that one of these large planets or objects, I think they're planets, looks like they might have a magnetic signature with these concentric circles. And this is the one from last night. I showed you briefly. Didn't have much time to put it on there, but we'll let it play through a second. See what I'm talking about? They took out all this stuff that's zapping around. That's what I mean by them peeling off the first several layers. And here's where we left off yesterday. 451 UTC. We had this weird looking bow shock pinched all out. So I'm going to pick up that run now in ISWA. But first, back to this sanitized version of the Mauna Loa Solar Observatory. So you see what I'm talking about? There's nothing zipping around. So they peel off first several layers. Anyway, and that's what we get that's what we're left. So either way, we get pretty good shot of what the heck's up there. And well, I think one of these is the big planet that passed ACE on October 16th up at the L1 Lagrange point. And it's been headed toward Earth ever since, and that's the big planet that's given us. There's the L1 Lagrange point, 930,000 miles in front of the Earth. It's where the ACE, the Discover satellites, solar observatory satellites sit to measure all the solar wind coming from the sun in order to give us an early warning to maybe power down some of these satellites when we get the high density CME type of thing coming through. And this is solar ham tutorial. I just clicked off the Lagrange point, so they're both in here, and this is in my description box. This is actually a representation of a screenshot what happened back in 2013 March 16th, and that's a CME. Now you can see what a CME looks like. See the phi angles all screwed up, the BT and the BZ, it's all screwed up. And see, normally it runs along, they run along pretty well parallel. But this is how our interplanetary magnetic field structure has been looking for the longest time, with Nemesis in the picture. And this is the phi angle. Can't reiterate this enough. This tells you exactly what's going on. If it's 0 degrees, that means we have a connection, interplanetary magnetic field connection from the Earth to the Sun. If it's at 180, it's the Sun to the Earth, and I get somewhere in between. It's sort of relatively in between. But look at the phi angle here. This is Discover. This is the one they put up in 2017 to replace ACE eventually, which went up in the 1995 or 97. But they're both still up there and they're both still operating. Here's the phi angle, this blue. So like I showed you, anything above 180 indicates a connection to a solar object behind the planet. You can see these numbers here. And they actually changed this one from 0 to 360 to 40 to 400 due to the backside connections, frequent backside connections. So there's what I'm talking about. See how this BZ and BT are all screwed up? Looks just like a CME. Same with this. Looks just like a CME. But of course the one on solar ham didn't go above 180, I don't think. Well, yeah, it actually did. That CME impact knocked it above 180. That's pretty crazy. So anyway, that's the status we're in right now. Solar wind speed's coming up. Density went back down. So whenever we made the connection with Nemesis, the backside connection got established. You can see the density started going up. It was actually going up there even when we were still mid-range. But the density went way up there for a little while. Normal is 4 to 6 cubic centimeters, 4 to 6 atoms per cubic centimeter. But now the density is coming back down, which is good for the planet. Solar wind speed's coming up. On Enlil, they never predicted any of those density spikes. Here's the plasma density up here. And this is the about where we're at date-wise, in the middle of January 5th. You can see the density even back here on the 4th, beginning of the 4th, was never going to be even up to 10, but I just showed you it went way up. The looks like the solar wind speed predictions are pretty accurate. As you can see, the density went way up. Here's the last 3 days on the Discover. You can see, okay, the BT and the BZ connection were running fairly stable, parallel to each other. Then around the 4th, things started getting whacked out again. I think this is where I showed you a couple days ago where they actually were intertwined there for 29 minutes. And that's when the density spike started coming up. Well, no, that was actually before this run. But there it happened again. They met, and you see the density starts coming up. So whenever the interplanetary magnetic field structure gets all screwed up, you can see the solar wind density starts piling up. And as I just showed you on Enlil, their space weather prediction thing, solar wind space weather prediction center, they no way at all accounted for that density. Okay, here's geospace. Before I show you that ISPO run real quick, here's what it looks like, the pressure right now. I think this pressure thing, well, the density, that's what I wanted to focus on. The density. Now, if we get solar wind density behind the planet, like we sometimes do in the front of the planet when we get these CMEs, I don't know, man. And then if we get a high solar wind event from Nemesis at the same time, which we had last night, wow, I don't know how the planet's holding up, to be honest. You can see it's getting up to be a more hostile environment. Here's these waves coming through, being thrown in from that big planet out in front. So let's get here real quick. So remember, 451 is where we left off. I got these things synced. They're running together. So there's 451. So we'll let this play through. You can watch these. I watched the solar wind numbers. They never went up again above 700 anyway. Couple sevens in there. The reasons I have these pulled up, remember this is when the density spike, or when the solar wind event occurred at double aught 31, remember? So these things were running pretty good, these fuck radiation belts. Then when the high solar wind speed event occurred, we got a lot of missing time there, like an hour and a half or an hour and 20 minutes, somewhere around there. So this must have got flooded around here. I'll just start these things running. They're roughly well synced. And these three are synced. And so I'll just let them play through. Check out in my description box, you can pull up the solar hams tutorial, the L1 Lagrange point. You can pull up the MLSO. I got a link for geospace in there. I know some of the links are probably corrupted. YouTube has a tendency to do that to my stuff, but and then just check out the stuff in my comment section. Click newest first so you see them all, and this looks like the ones I put in there about the physics of big planets being close to the Earth and how that's possible or are being overlooked, because nobody ever gives me a thumbs up on any of that stuff. But electromagnetism rules the universe, not gravity. Gravity's as much as 10 to the minus 40th power less than electromagnetism. And that's the first link in there if you click that newest first. I guess that's about it for now. I'm going to keep monitoring the situation and keep you up to date as things merit. As God bless. Running out of time. Peace, and I'm out.